Hello, everybody. This is Group 3. I'm Stefanie Kozera.
I'm Alexander Ivanovic.
I'm Matt Horvath.
Devin White.
And our project is a weightlifting form check for injury prevention. So a brief introduction on our application. It takes a live video feed from a user and will superpose a skeleton of all the major joints on the body, and then determine if somebody's form is good for whatever exercise they're doing. In this demo, we've included 3 exercises. We have a bicep curl, a shoulder press, which uses both hands, like you're holding a barbell, and a squat. And our application is capable of working on both the left and right side of the body. We have all this stuff tucked away in a user interface, so the user can switch between options. To achieve this, we used a well-known neural network that's capable of finding every joint on the body. And then we used an algorithm we found to determine the angle of a line like up against the unit circle. So the x-axis being 0 all the way around to 360. And we believe this application can be used to help prevent injury for novice weightlifters, especially if they don't have a spotter to help them. It can be difficult to ensure you're using proper form when you're new to weightlifting. So next up, we have our demo video.
Skip the intro. We already did that.
And I'm Devin White.
And this is our demo video.
Everybody can hear that, right? Just want to make sure. Okay, cool. Hello, everybody. This is a demo of our ECE 4510 final project in which we use some human pose estimation to help a user perform different exercises. As you can see, it's going to be drawing different segments on our body as we do different things, and it'll change colors accordingly depending on angle. We're going to start with the squat. So for the squat, as you can see, it's going to be looking for your back location as well as your hip to knee and your knee down to your foot. If you don't go down deep enough, your right leg will not go green. You need to make sure you get down deep enough. That way it's green. And you also want to make sure you're not leaning over forward too much. As you can see, in this case, I lean over forward, my back turns red. Make sure it's nice and correct. Get down low enough. If you don't go down low enough, that stays red. Your leg will always be green because the angle of that is pretty fixed into how your body naturally moves. So there's not much change that's going to happen there. As you can see, it responds accordingly to what things you're doing. We also have the option to flip it and evaluate. If you want to look from the left side, same process, looking for your back, looking for your hip, making sure you're low, making sure your back is as straight as it can be. Like I said, don't want to be leaning over too forward. For our next exercise, we have a shoulder press. So for this one, it's going to be looking for the location of your. It's going to be looking for the location of your wrists. The big thing here is that when you're going up for a shoulder press, probably using a barbell, you want to make sure that you go up evenly. You want to make sure that you're never like this, never like that. So as you can see in this one, all we're really looking to show is the angle between our wrists. So you can see the actual connection that we have made there is going to be either red or green. When it's green, it means you're going up at a good pace, like that. So if you go up too far, like that, it's going to be red. The big thing here is when you actually had a weight, when you actually had a barbell, you'd want to make sure you go up nice and slow, but at a good even pace to keep it even. As you see, it's kind of hard to do when you're not holding weights. But this is going to make sure that the user doesn't get overextended one way, lose your balance, especially like me. In this case, I'm sitting on an exercise ball right now. So if you were to start getting overextended like that, you start leaning one way, you wouldn't want that. As you can see in the top there, that's showing the angle. It pivots around the unit circle. So it's either going to be 0 or 360. We have it set that as long as it's within about 12 degrees of 0/360. So if it's above 348 or if it's below 12, it'll be green. That's how you know that you're doing the exercise correctly. Lastly, you have the option to do a simple bicep curl. So the bicep curl, allow me to readjust my camera. There we go. So the bicep curl is going to be looking for your shoulder, your elbow, and your wrist. And this one's probably the simplest of them all. Really want the user to make sure they can keep their upper arm as straight as possible, back straight. Simply raise your arm up. Very straightforward. Easiest one for us to implement. As you can see, you don't want to get overextended forward. A lot of people, what they'll do is when they have heavy weights, they'll end up doing like this. You can see they'll turn red if you really start leaning into it if it's too heavy. You don't want to do this either. You can kind of cheat your way through a bicep curl if you have your arm back too far like that. You want to make sure it's nice and square as you come up. We can also do this for the other side as well. Simply choosing the left side. As you can see, it simply will let you know if you're too far forward, too far backward. It's going to compensate if you lean forward, if you lean backward as well. So that was a quick demo of our ECE 4510 final project. Okay, so now we'll kick over to the live demo. I've turned my camera off. I'm going to go ahead and fire up the application, and then I'll share that application. Okay, there it is. Let me go ahead and share it. Share screen. Okay, hopefully you guys should be able to see that right now. Go ahead and set it to squat. As you can see, here I am today. Pardon me, I actually had a nice jacket on this morning, but it actually doesn't work well with the jacket. It looks like it really wants some skin tone, so it's kind of a real world implication. But as you can see, it's set to evaluate the right side. So if you were to go down, hang on, adjust this camera, make sure it gets the foot. If you were to go down all the way, much the same as the demo video, you want to make sure you go down all the way. Don't lean over too far forward. Make sure you're nice and even like that. You can also do it with the bicep, with the shoulder press. Again, just emphasizing the importance or the benefit of something like this is that, you know, if a user was able to, if a user was ever in a situation in which they were by themselves and they were doing some heavyweight shoulder press or something, they'd want to make sure that they're going up nice and evenly. You don't want to ever get too far extended one way or the other. You can really hurt your spine if you were to lean over too far one way or the other. But as you can see, follows your wrist. It's very dependent on the camera location, making sure you're square with it. That's one thing that maybe we can improve upon in the future. And then lastly, just to show the bicep curl one quick last time. It's looking for shoulder, the elbow. Simply do bicep curls. This one's a little weird because it doesn't actually incorporate the back, so you could kind of cheat the system if you were to reorient your arms. But for the most part, it works pretty well to make sure you're straight and even when you're doing your bicep curls. This one's probably the least effective one when it comes to protecting against injury. You know, bicep curl, you're relatively safe. But to be fair, if you are trying to lean into it like this and it's going red, you're probably doing too much weight, and that could cause a bicep injury. So that was our quick live demo, just a rehashing of the pre-recorded demo, and now we'll go ahead and get back into it. Okay, so now that we've seen the demo, this application uses a multi-stage convolutional neural network in order for us to actually get the location of the body parts on the human. This neural network takes in the input image, which in this case would be a single frame from our video feed. It also takes in 15 different points. These 15 different points correspond to elbows, shoulders, knees, ankles, the neck, hips, stuff like that. And what we're actually looking for are pairs of those. So 2 to 3, 3 to 4 in this case, in this example, is actually the right shoulder, the right elbow, and then the right elbow to right wrist. So this is what we would use when we do the bicep curl. So this is what we're actually going to want to pull the coordinates out from the neural network when we're doing the bicep curl. In order to actually implement this, we actually made use of the DNN module within OpenCV. This allowed us to actually use some pre-trained convolutional neural networks and weights and biases. We did not train it. We did not design the actual neural network. We found some really good examples through the Max Planck Institute of Information, which is actually seems like it's a university over in Germany, and they actually set up a free-to-use pose estimation neural network in which they did their own training, their own weights and biases. They actually trained it using a database of over 25,000 different images of people doing different types of things. They're all categorized. And what's nice about this is they actually have some categories in which people are doing workouts. So they actually trained it on people doing bicep curls and shoulder presses and squats. This worked well for our application because that's what we wanted to do. So we figured we would go ahead and try that model. For the most part, it worked well. We did have to do some tweaking with some of the outputs. But for the input, as I said, it takes in a single frame and it goes through a VGG19 neural network, which is 16 convolutions and then 3 fully connected layers. These convolutions and pooling the layers, what they do is they'll take the input image and they'll isolate me, and then they'll break it down into simpler components and build it back up. And the benefit of this is when it goes to our fully connected layer, it can process a little bit faster, but also it gives it a cleaner image for it to do its classification. It gets rid of a lot of the junk which it doesn't need, which can often cause issues when you just use a simple fully connected layer. So as I said, this VGG19 setup uses 16 of these convolutional and pooling layers. So the bulk of the work is simply breaking down the image to small pieces and then building it back up. That way you have a simpler image for the network to classify. So that's the input stage. And then the stage 2 and 3 of the system actually are the fully connected layers. And this is where we actually get an output, a 2D probability output map. So the output map will actually have like, it'll say for point 0, here's a 2D array. And that 2D array is going to be a map. And along that map, you'll see hotspots. And if those hotspots are high enough, we'll accept that as the point of which the shoulder is. So when it's looking for point 3, which I believe is the right shoulder, if you look all across this map, and this is just a simple visualization, right? It's just an array of data. But if it's high enough, we'll know that, okay, that's probably where the shoulder is, and we'll go ahead and accept that point. When we accept that point, all we have to do is actually pull the XY coordinate off that 2D probability map. And now we actually have a real world location of this 2D, well, I shouldn't say real world. We have a location on our image of where the neural network has told us it thinks the right shoulder is. With this information, we can start piecing together an actual skeleton, drawing lines and everything. And now I'll kick it over to Alex to explain some of the angle work we did.
The actual mechanism for deciding whether or not our person is out of form is by checking the angle between one body part with respect to another. And to do that, we would assign one body part to serve as like the origin on a unit circle, and then the other would be like an object moving around that circle and would return its angle. So as an example, if you look at the arm that's in this picture, we would have his elbow serving as like the origin, and then the shoulder would be that object. So in this case, it would show that his shoulder is at 90 degrees, which would be in good form. Before we could get to that point, we just had to write some code that would just detect the angle between two objects in general. Next slide, Matt. So the way we tested our angle code was just by performing an angle calculation between two different colored objects. And to do that, we just created a mask using hue saturation value to only detect certain colors. We would assign one color to be like the origin of the unit circle and another to be an object about that. And then from there, we would calculate their vertical and horizontal distances to get a hypotenuse, and then use that to perform trigonometry to actually calculate the angle. Next slide, Matt. Thank you. And these are pictures of just the angle code working by itself. So if you look at the bottom left picture, the orange would be our origin point for the unit circle, and then the water bottle was our object or trying to find the angle. So in the bottom left picture, it's showing at 0 degrees. The top right, it's coming around. So it comes to 197 degrees. And then in the bottom right picture, it's up at 28 degrees. For the actual like implementation of the angle code to talking to our neural network, we got rid of the part of the code that detects the colors of the objects, and we replaced the locations of the colors with locations from the neural network. And Devin is going to talk more about how we accomplished that.
Okay, so kind of bringing it all together with the angle calculation and the convolutional neural network. So what we did is for each exercise, we determined the important joints, because the neural network wants to show all the joints it can detect, but detecting all the joints not only makes it kind of messy, but it also slows the program down. So here in the image, you can see that he's doing a bicep curl, and we determined that for form checking, the only important joints are the shoulder, the elbow, and the wrist. And then you can see that in this example, he has good form, so the lines between the angles are green, like shown in the demo. Next slide, please. And just kind of getting into that further, this is the example of the squat. So for this one, we determined that there were 1, 2, 3 important joint pairs. So from the head to the hip to the knee, and then the knee to the foot. And then you can see in the left that it checked that the head to the hip angle is red because he's leaning too far forward. And then in the right, he remedied that, so he has good form. So it displays as green.
So some of the complications we encountered with this program, beginning with just some intricacies of the neural network, we found when we were working with it, it tended to snap to one of the major axes. So say you had like your arm was moving, it would kind of click in at like 90 degrees or 0 degrees before it had reached, that point. It wasn't very accurate when it was close to those major axes. This is probably due to the neural network. We're not really sure how to fix it. And we worked around it in the code, so it didn't become a major issue for any of our implementations. We also discovered there were issues with backgrounds. We needed very strong lighting for this to work. And also we had some issues with clothing. Once Matt had to change his shirt because it was too close to the color of this background, and the algorithm wasn't detecting any of his funny parts. And it was also a little awkward not having access to proper weight equipment. As Matt mentioned in the video, it led to awkward testing, especially with the shoulder press, because it can be difficult to make your hands parallel when you're not holding something with actual weight. So next slide, please. So one of I'd say the biggest blocker on this project right now is actually performance. As you can see from the video, it's a little slow. It doesn't run at a very quick frame rate. So one of the things we noticed on the neural network is it allows us an option of using either the CPU or the GPU to run these calculations. And via our research, GPU performance should be expected to be faster. So we tried to implement using the GPU for this algorithm, and we discovered we were having some issues with that implementation. It needed a more recent version of OpenCV than we had available, and we just ran out of time to actually implement it. But if we were to do this, we would expect it would increase performance, and optimizing hardware would certainly help this application work much better in the future. We also discovered some methods of maybe increasing the neural network performance by only searching for the required joints. As it works right now, it discovers every joint along the whole skeleton, or attempts to, and that certainly would slow performance. So in the future, we could cut down on the joints that we're actually searching for with the neural network, and that might improve our speeds. Next slide, please. And here's Devin again with the conclusion.
Okay, so just to summarize everything, kind of what we set out to do, we definitely had our expectations met because it does properly check the form of the user. And again, we accomplished this by combining a convolutional neural network with an angle calculation program, and then we edited those kind of to make them our own and apply them to what we wanted to do. And like Stefanie just went over, there are some limitations, but that could be fine-tuned, had we had more time, and we could add in more exercises and that sort of thing. But we do think that this program could be applied for fitness education and injury prevention practically, like used in the real world. And that's it. Thank you guys for listening. On our next slide, we got some references.
Oh, yeah.
Great job, guys. Really well done, demo and all. I really appreciate you guys putting in this time to get machine learning demo working. So excellent job. And let's open it up. Well, first of all, I was hoping that Matt, you're gonna do a live demo with real weights, or maybe
Yeah.
a small kid lying around lifting them up.
Yeah, I mean, I can. I got a kettlebell. I can do a bicep curl real quick.
Yeah, but still, we got what you guys accomplished here, a useful and a really practical project. I'm really impressed what you achieved here. Anyway, let's open it up for questions from everyone.
I have a question.
Dana.
Can you guys hear me?
Yep,
okay. So when you guys were doing the tracking, first of all, I would use this. I do a ton of weightlifting. Second of all, when you guys were doing the tracking, for some of the poses you were tracking side views only, and some of the poses you were tracking front views only. What's I mean, you could what was the thought process behind that, and why not getting front, side, and back views for all of the poses?
Yeah, so I think in an ideal world, we'd actually have like a multi-camera setup. You know, if you were to actually go to the gym and let's say you actually went into like where like squat racks are, there'd be like a little setup with cameras all around you, and you'd be able to do all of that at once and give you a more comprehensive breakdown of what's going on. For this purpose, like it's been said a couple of times, you know, we're all in our own house. I only have one camera right now, and also, you know, we didn't have a lot of time to implement additional features, but to focus on just the side views, I think it was the easiest way just to get a rough start on what this project could be as far as just determining angles, you know, especially with doing the squat. So I think that was the one that worked the best in my opinion, or it turned out the best. You know, but certainly, you know, in a real world, if you could also look at the front and make sure that your knees aren't going in and out, because that's a big problem when people do squats too, is that their ankles and their knees can be weak. So they actually, when they squat too low, their knees go inward, and that's really bad for your back and your knees. So I would say the main reason was just a time issue and a constraint issue with living in a COVID world right now. But for sure, in a full-fledged application, I think you would have multi-cameras. You'd have a lot more data. I agree with what you're saying. Yeah.
Well, just even if you didn't have that, even if you were just a person at home, like getting some. I mean, ideally, getting some of those other views in there, because the person could do one and then have it recorded and then turn and then do one and have it recorded. I don't know. It just sounds like it would be really cool.
Yeah, and to get a full, I mean, like to be like a real like safety performance or a safety checker and form checker, you would definitely want more cameras. Definitely at least a front and a side for sure, in my opinion. But yep.
So Dana wants it a real product. Okay, so you guys have to kind of.
It's shipping next week.
Dana wants us at our house for COVID now.
So another thing you could do is that try to detect what side you're on to figure out, are you side view if with a single camera, front view, so you can switch over to, you know, a different.
Probably another one would be actually you just do like one or two of the exercises, and then it knows that, hey, I think you're doing a squat, I think you're doing a bicep curl. Like I said, we didn't actually design this neural network. The neural network's actually just a text file, and then the weights and biases are a text file. And using the DNN module, you literally input it and it sends an output out. We had to build around that. But, you know, the scope of the project, in our opinion, wasn't to actually design the entire neural network. Most likely, you know, use the tools we have available, use some really good resources out there, and kind of modify it for an application, which we thought was kind of cool, which is what we did. But certainly, I think, you know, being able to, I think the coolest thing would actually be and as Dana says, if you have multi-cameras and if you can just start doing a workout and in about like 2 seconds, it says, okay, I think you're doing a squat. Here's what's wrong. Here's the angles. I think that would be like a full-fledged application, which would definitely be useful.
Very good. More questions?
I got a question. Any thoughts on or options to add the you know, to count reps, or, you know, chart the perfect rep or failed reps, and then maybe make a positive negative sound while you're doing it?
Yeah, that would actually be actually, we didn't even think about that. That's actually would be pretty easy to implement. Yeah, because we can actually just check the location, and if it's ever all green, maybe that's a good rep, and that's a really good idea that we should have thought of. But yeah, that'd be cool actually. Yeah.
For the squat, I don't think it would even be hard. You just check if you got to the right depth and if it was all
Yeah.
green.
I think we could actually implement that fairly straightforward with what we have now. It's a really good idea.
That'll be 1,000 for my consulting fee.
Okay.
Lots of people here who want it as a real product for exercising. Okay, more questions, please. Anyone?
I don't have a question, but I just have a comment. You know, given the time that they all had to work with their projects, I'm very, very impressed with the results. And I think, you know, with COVID and having to work remotely, I think they've, you know, been able to come up with innovative ways to find solutions to things. And I think that's really, really key to just the whole, you know, learning process and working together in new ways. So I just have to compliment the students for their work.
Sam, that I
Thank you.
totally agree with you, and that is why this is so impressive for me, that what you guys achieved by yourself and just coordinating online with your group and having a group project and able to present it with all the problems with the Zoom and all meetings. So don't be you know, put back by any issues you had or even presentations. You guys did a fantastic job, all of you. I totally agree with Sam there.
Yeah, and I do like, you know, the fact that all three projects were created to benefit somebody, you know, to do, you know, something positive or good. I like that. You know, not just for entertainment purposes.
Well, I don't approve those projects then. Just kidding. Okay, more questions? So one question is, a lot of times you see this kind of application where you have sensors on the body. So you can track the body position. A lot of times you see that. So what do you think? I mean, we have machine learning at this point that a simple 2D camera image is reliable enough to do this tracking? I mean, what I saw in the video was an excellent result. I mean,
It was a,
yeah.
if I don't mean to interrupt, but actually it would be a lot better. But as Stefanie said, so the input image is actually scaled down to 150 by 150. Because it's like, so like I said, this runs on my CPU and it's kind of chunky. But like I said, the input image is scaled down a lot. Like it should, if it was full resolution of whatever the camera can do, it'd be a lot more accurate. But when we did that, it would take like, it was like half a frame a second. So it was more so, it seems like it's more conducive for like processing like a singular picture or an image rather than a video feed, which is unfortunate. But even like you just said, though, it's still fairly responsive and it works pretty well. Especially, like I said, especially for the squat. I feel like the squat one worked really well.
Yeah.
Just
Well, I guess for the future classes, I have to get some Jetson nano boards from NVIDIA for you guys, whoever is doing machine learning. That way you have a good GPU to run it on.
Well,
dedicated hardware would assist a lot.
I mean, I have
feel.
a 1080 Ti, so like it would work, but like we couldn't figure it out. It looked like it was so simple, just a couple commands, and it just wouldn't work. So I don't know what the issue was.
Well,
how fast a processing speed do you need to do that? I want this product. So how fast do you need?
Probably not.
We couldn't even get it to run on my computer, Stefanie's. It's pretty demanding.
I'm willing to bet, like if we had like some real time, you could definitely improve the neural network performance. I'm sure there's a lot of overhead there. It's probably very straightforward. It's straightforwardly implemented. It's nothing crazy, right? It's just a rough example. I'm sure someone really smart could figure out a way to get it to run on your phone. I'm sure.
And like I was saying in the presentation too, I feel if you could cut down on some of the processing it's doing, it would greatly improve speeds. Some of the feedback of this network online, it's very common to be slow for people. I feel like there's a lot of space for optimization in that.
Yep. I mean, if you had enough time, I'm sure you're gonna address some of those things and efficiency issues and all. One question about the angle detection. So were you detecting relative angles between the links, or you were actually detecting absolute angles also?
It was relative angles between the links.
Okay. So yeah, that's what I thought. That way you don't need to calibrate the camera to vertical position and the body, because then you will need one extra step before to
Yep.
actually measure the angle. So that's great. Any last questions for this group?
I just wanted to add to your comment, Professor.
Yes.
So you mentioned that you kind of wanted to see it work with also sensors putting on the body too. I think that if it were to be like a final product, it'd probably be better to leave those sensors off, just because if somebody wants to go maybe use it in the gym, it'd be easier for them to just walk in front of a camera than it would be to go and put a bunch of sensors on and make sure they have them, you know, they're wearing them correctly.
I agree. I agree. Yeah, I mean, this, if you can just walk in front of a camera and just do some exercise and it's just remotely monitoring you and maybe beeping, hey, watch your form. That's really good. You know, that's for a home use and this kind of use, it's excellent. Yes. Thank you very much. Good job, guys.